Hey guys, how are you doing? It's Simon from Bizlearn. Hi and welcome to a new video of my series NX Freeform Secrets. In the last video I showed you how to add pictures to a block, which I'm going to use as a template for my design surfaces. And it's a magic mouse, as you can see, obviously. And if you want deep explanation of the import images stuff, you should watch the video, which I'm going to link to the upper right now. However, we are going to work with the XForm command to create this top surface, and simultaneously going to be using some analyzing commands to make sure that everything is fine. How fine shall the surface be? Well, it looks like a sphere from all the perspectives, but it's not a sphere, so we have to use freeform surfaces. The question now is the quality of a surface. Shall it be class A? I believe that the designer of the Magic Mouse was using class A methods to create this. We're not going to reach class A at 100%. We're going to do a trimmed class A surface. What that means, I'm going to tell you within the next few steps. Before we start creating an XForm surface, I have to trim my block, because I need all the outlines here. Why can I trim it? Because the mouse is symmetric in X and Y, so it is possible to do that. And I'm going to extract the top surface via extract geometry. It's face and it's fixed at current timestamp. That's important to do. And you can hide the block as well. What you could do now is create your mirrors before you start. That's possible. So I'm going to use extract geometry again. And mirror body. And additionally, I'm going to disable this option, fix at current timestamp, because this will cause the mirror body to move independent from the current feature to the latest position after modifying it. That's pretty cool. Next thing I'm gonna do, I'm gonna enable the reflection analysis related to all of these faces like this. This reflection analysis visualization gives us some information about the consistencies, and we have some kind of tangency in here because the planes are coplanar, and also a curvature continuity. We don't have a curvature on this one and on this one, so we have some kind of curvature continuity in here. And this is something we will have to check during the XForm modification. And that's what I'm going to do. I'm going to start XForm via surface, XForm. And it's very important now to select your first original surface. It's this one, not the copies. And we have a parameterization information here, where we can declare values. And what you should not do is increase your number of patches, because I told you before that I want to create something close to a class A surface, meaning a trimmed class A surface, and therefore it's very important not to create additional patches. It's our goal to have only one patch. Well, normally class A means that we only have one patch on the overall structure of a surface. That's what we won't have, because we're creating one quadrant, which we're gonna copy somehow. But we have to do a modification in here. For example, if I move one of these poles, which you see here, I'm just gonna move it into Z direction. Just select one of these axes. And if I move this one, I'm no more tangent in that area. And you can see it by having a look at the reflection, because if a reflection is no more smooth and you have gaps between your reflection lines, this will tell you that we're no more tangent, we have an angle between. By Control and Z, you can undo an operation. What we have to do is to increase the degree. I'm going to use degree of 2. So we have 3 poles in each row into U and V. U and V is some kind of coordinates within your face, like X and Y. And what I'm going to do now, I'm going to move rows like this. I'm going to select a row. I'm just going to orientate my view a little bit like that and just move it into my Z direction, which is declared here. Now you can see we're really approximately matching the image behind. And the problem is, you can see I would have to move this row up maybe, which is not possible because then we're no more tangent, but I can move it to the left instead. I'm gonna select it, orientate, and then move it to the left. That seems to be good. All right, let's have a look at the front view. I'm gonna select this row and move it into my Z direction like this. And of course, there is no update right now of my copy, so I'm just gonna apply this. And we're still tangent and we're still curvature consistent. If we had an angle between the lines, it would tell us that we're still tangent but not curvature consistent. Curvature consistency, what does it mean? Well, tangency means that if you create a section here on your surfaces, the resulting lines would be tangent, as all of you are familiar with. But curvature consistency means that it's not just a tangency, it means that the radius value on each endpoint of our section are equal. And that's the case because we've created a mirror. So I'm gonna have a look at this side again because there's still some imperfection. So I have to edit my X-form again. Do not just double click and edit with rollback, right click and edit parameters instead, because if you do that, edit parameters instead of edit with rollback, you also get a proper display of your analyzer's commands. And I'm gonna move this pole upwards like that to also match this outline here. The top surface is fine so far. It needs some fine-tuning, of course. We have a nice reflection, but there's something else I always check on my surfaces. It's called face curvature. I'm going to select all of my faces now, and you can see the type is Gaussian. And what you see here is the Gaussian curvature values of my areas here. And blue is telling me that it's some kind of flat compared to this area, meaning it's also flat here compared to this area. And you can do this to adjust your, well, bumpiness of your surface. But anyway, if you really want to fine-tune this surface, I'd recommend you to use the face curvature analysis. And you can see it within the part navigator to be disabled and replaced by some other visualization, however. But anyway, if you start X-form again, right click and edit parameters, and you do a modification of maybe, let's say, this one, I'm gonna move it to the right a little bit. You can see a rough preview of your bumpiness and the influence of moving this pole. And I'm gonna cancel that because I'm not gonna fine-tune anything within this tutorial. Just wanted to tell you that there are possibilities. Another possibility you have is to increase the number of poles. I recommend you to use degree of 3, then you have 4 poles, which I did already and allowed me to really fine-tune this surface, because right now we only have a couple of poles that we can move because we need to maintain the tangency. And you can see that this line and this line and this line are coplanar with the top surface. So, no, well, it's not coplanar, it's moved, but it's parallel. And this one as well. And that's very important to maintain, because if you move this one into Z, you will create an angle between this surface and the mirrored surface. So the last step before this video can be finished is my outline here. If you have a look at the top view, it's this one. And I'm not going to create a spline for that. I'm not a fan of the spline. I'm a fan of faces directly. Why am I using X-form instead of creating, well, 4 or 3 splines to create a surface? I did already, but the problem is I want to run the analysis simultaneously, and I want to analyze my surface, and I want an information what happens to the surface when I'm moving a spline, which I don't have when creating splines and, for example, through curve mesh or studio surface afterwards. You always have to apply and see, apply and see, apply and see, or check the spline curvature, however. but you won't receive an information of the overall surface. That's why I'm using XForm for just some of my design surfaces. And I'm gonna do this for this outline as well. And I'm gonna use the section surface. I need a cubic transition. I'm gonna use fillet and bridge, and it's pretty easy to use as well. And also here we just need a tangent continuity. It's not necessary to have it curvature consistent, because it's a mirrored surface and it will be curvature consistent when using tangency here. If you have no idea what I'm talking about, I am offering freeform trainings for beginners and experienced users, which have a specific name, because typically freeform trainings offer you a wide range of function explanations, but not really explanations of methods or mathematics behind. And I believe this is something you need to really increase your freeform model stability. That's why I call my course the transition problem, because that's all we're working on, transitions. Creating freeform surfaces is a kind of creating transitions. However, let's proceed. We need some fine-tuning here, and that's why I like this option. We have a bridge command, which gives us the possibility to dynamically drag and drop the surface, but it's not possible in here because I'm relating to a solid body and not a surface. But what you can do here is increase your depth, for example. And there's something you have to do before. You have to enable analysis before, because otherwise you don't get an information of possible inflections. Just have a look. Can you see this inflection here? It's very large, and we won't be able to trim our top surface. This is a prerequisite we have. And the problem is, if I just decrease this a little bit, you don't really get a nice preview in that area. And therefore we have some analysis we can use. For example, you can use show poles. It just gives us an information about the mathematics of the surface, because we got one pole, a second pole, 3, we got 4 poles, meaning we have a tangent transition here and a tangent transition here. And tangent transitions, as you've learned within the XForm command, require 2 poles which are aligning a polyline which is tangent to our mirrored stuff, or however the top surface. And it also tells me that we only have 1 segment in here, which is also very important, and that's why this is one of my favorites to be used. I'm gonna hide my block because it's not required anymore. Select my surface and start the section analysis. And I'm gonna use isoparametric, which is U and V, and you can see U is these sections. This is my U parameter, and this is my V parameter. That's what I need, and I'm just gonna decrease it to 3. And of course, show comes and suggest a scale factor, which I'm gonna increase a little bit. Because if I had an inflection in here, I would have a needle on this side. And if I zoom in, there it is. So the problem is, if I trim my surfaces, and that's what many people do, they don't see that because they're not using analyzing. And I recommend everybody who's creating splines on surfaces to use analyzing tools. Don't do it without, because the result might be bad. The problem is, I am maybe able to trim that. Let's have a look. I'm going to use surface, trim sheet, and I'm going to trim just this one on this face. Here is my region to be kept. Okay. And the trim is working. But the problem is, if I control my edge, and I'm going to do it with that one because I'm going to leave this displayed. Analysis, and it's called curve analysis. Select your edge. Can you see that? I'm going to set this to single curve. Can you see this? There is a gap. There's an additional edge to be selected. What does this tell me? It tells me that there's an angle between. Very obviously, there's an angle between, and it tells me that these lines are not tangent. And that's a problem because of my trim operation. And you could go on, you could create a thickened body with that. You could create all the rest of your construction, but you will always struggle in this area. And this is something that can be avoided by using curve analysis. What can we do? Maybe I'm gonna leave it on. Why not? I'm gonna use single curve instead. And you can see there's another section and curve analysis listed now, which you can easily hide or show. And I'm gonna go on with my section surface, right click and edit parameters, not edit with rollback, because now I get a nice preview of my surface. And of course we have to fine tune a little bit, so we have to work on the skew like this and on the depth as well. And you can see now it's a very, very rough inflection in here, but it's getting smoother and smoother, and now it's gone. There's no inflection anymore, and really close to the final result. Of course, we can fine tune it, and it will be possible to reach this template curve, no problem, because I did it already in here and it worked. But I guess it's time for you to do hands-on. You saw the first video to import images, which you can find on the internet, and you can now try using the Xform and all these pretty cool options like mirror body, which is not fix the current timestamp, and all the other options to give your best and collect the knowledge about degrees and however. And let me know in the comments if you have any question or struggling with something. I'm gonna upload a next video, of course, because we are going to finish this magic mouse. I'm also going to do some explanations around it, some background informations, that why I won't do the overall process at once, and hopefully you understand that. However, if it's your first time on this channel, subscribe it and be informed automatically about new video content which I'm uploading several times within a week. Have a nice day. Goodbye.